want you to look. That's the first thing I want you to look for. You see one?
At the top of the...
Nice. He goes right at the top. So when I'm at boom, boom, right there, and I'm actually going to draw the slope of it, like slope 0, right? Now, what I want us to do, right away, come down here. Go straight down, and I want you to put a dot right there. You know why? Because derivative means slope. And what's the slope right there? 0. Do y'all follow me? I know a lot of you are copying. I'll wait till you're done copying. But that's what's going on here, really. Hey, your f prime is 0 here. F prime means derivative. It's 0. Slope is 0. F prime is 0. M is 0. M means f prime. F prime means derivative. And you go, what does this mean? This means slope of tangent drawn to f. Right? It's the slope of a tangent line drawn with the curve. So, okay, there's the slope of a tangent line at 0. If I'm graphing the slope, then it would be what right here? 0. So far, so good? Yeah. Any other spots? Let's do it. Right over here. Hit these first. Go down. Go down. Right here. There it is. Go straight down. Why is it right on this x-axis? Because the slope is 0 right here. F prime is 0. F prime equals 0. M equals 0 there, right? Now, to finish out a rough, we're just making a rough sketch of this graph, by the way. To finish this thing out, let's now look in between. In between these spots, because there's no more slope to 0, true? Right? Cool. Let's go over here. Would you just put a tangent on that thing and tell me if it's positive or it's negative? So I'm just going this curve. Just how about right here? Is that slope positive or negative?
Positive.
So I'm going to write f prime pos, and then I'm going to come down here. I won't even do the dotted lines anymore. I'll just come right here, and I'm going to put a dot up here somewhere. I'm just estimating. You go, where is it? Well, I'd have to know exactly that slope, right? I'd have to actually measure I'd have to measure the rise over the run there. But I know it's positive, right? So where are the positive values? Up here. Where are the negative values? Down here. So I'm just going to put a dot right here, like, how about right there? That work? Now, everyone, how about in between these two slope of 0? What's going on, like, right there? I'm going to put a tangent line arrow, and here we go. What's that slope?
Negative.
F prime is negative. So, I'll just come down here at this location, put a dot down here somewhere. Where do I put it? Well, I just know it's negative. I have to measure the rise over the run there. That's a bad looking tangent. We'll make that look a little better. Tangent hits that thing in one spot. Get that. There we go. So that, negative. Hey, one more. How about over here? What's the slope right there? Slope's positive. There we go. Boop. And just put a dot right up here. The last thing, everyone, you bet it'll be nice and smooth. Just connect all the dots. What would this do? It looks like this would come like this, right? It might loop over. It doesn't have to be perfect, but it should come down like this. There we go. By the way, this probably would kind of loop over like this. If you really wanted to know this design, it would probably come over like that. The only reason I know that is because I could tell the slope was really steep and it was getting close to 0 there. So it kind of fade in like that. It could be more like, yeah. But remember, you're just doing a matching. You're just doing a matching. And you continue. Cool.
Now, because the tangent at like 0, 0, for instance, there is negative, is that why you put it down?
That's right. And you notice, you go, well, where should I put it? You're like, listen, I'd have to go in here and measure the little change in y or the change in x to that. We don't have to do that. We're just making a rough sketch.
But you could just put it like right below it.
Right below it. And that's good enough. Or you could have stuck it like way down here, you know, because you're just getting a sense of it. And if you're wondering, like, do you have to make a perfect sketch for me? I do matching. I think it's very fair. You know, it's the best way to go.
That's all we have to do for every break.
Yeah, I'd give you like, the book did this too. I'd like the design. No, I do, Joe, I'd probably give you 4 graphs on the left, 4 graphs on the right. I'd be like, can you match these 4 with their derivatives? And once you did like a couple of these points, you'll figure out where it is. And let me give you another one. All right. And that's what we'll do. We'll just do a bunch of these to the end. If you want to create one on your own, you can, we can, and we'll see what it looks like. We'll look for strange scenarios. All right. What's my next one? All right, how about just this then? How about this? Can you hear? Stop there. Just one up. Yeah, I mean, seriously, just something like maybe a parabola or something. But I didn't give you the equation of this, so I don't know if you knew, everyone. Maybe that's y equals x squared plus 1. Or maybe it's y equal to x to the 4th plus 1. So we're just going to make a rough sketch of what we think the graph's doing, right? In fact, I could even make this thing really kind of flatten out here. Don't worry, I'm just going to make it be more like, you know, right here, it just came down. Then I was like, all right, it's the bottom, slope 0. Because graphs like y equal to x to the 4th, everyone, do stuff like that. Graphs like y equal to x to the 4th. They get really, really, really low slopes right there and there, but then it hits this bottom part. It's its lowest point there. All right, where's the slope 0? Everyone can see it. Do you agree? Right there. That f prime is 0. So where do I put the dot? Where does this go? I mean, does it go right here? No, it goes where? Right there. Someone agree? Because that's where slope is 0. This is where slope is positive. This is where slope is negative. True? So far, so good? Sure.
Because the bottom is kind of flat, it doesn't extend, does the...
Great question. There was one instant where it got totally a tangent slope would be 0. But then it just barely started increasing up this way.
So even though it's like...
Yeah, it just had a little lift and it kept going up. Like a very, very what? Not a very high slope at all. And just right after it hit that point right there, so I didn't want you to think it flattened out from like here to here. It was a straight line. It came down, back. Yeah, and just like a parabola, but then it did get some lift. But there was only one spot right there where it did it.
If you have like x to the 10th power,
Yeah.
what will happen?
X to the 5th?
No, x to the 10th power.
Oh, exactly. Yeah, and feel free to look at it in your calculator. It does that.
Would
Just
it
kind of
be a
gets me in.
point? Would this be a single point?
Yeah, it'd be this 1 point. Yeah. You know where it is? At x equal to 0. X to the 10th, x to the 12th. You bet. Oh, and I got my dot right there. Now, what's going on over here? It's negative. That one agree? You ain't have to mark it up, but I'm just going to go like this. Negative, and just come down here and go like that. Negative. How about right there? Positive. F prime positive. Right there. So what's this graph doing? Something like what? Maybe it's just a straight line, or maybe it's just a curve that has a little lift to it. Just a rough sketch, but isn't it doing something like this? It's kind of sloppy looking, but yeah, isn't it doing this? Yep, you bet. Now I want to point something out. What if this was y equal to x squared? Joe, would you try to do the derivative on that? What would be derivative of y equals x squared? Just so we can make connections here. Y prime would be a 2 in front, x, decrease the power by 1, right? And is that a straight line? Straight line, parabola. Does everyone see the connection here? See how but you could do this with any graph? Now what if this was, here we go. I'm going to do yours really high power. What if this was x to the 4th maybe? Plus a, and look, it's shifted up, so plus a 1. What's that derivative? That would be a what? 4 in front, x, decrease it by 1 power, 4x to the 3rd. What's the derivative of that? 0. So and what's 4x cubed look like? What's a cubic graph look like? Yep. So it'd be more like, but it'd still do this. That's what I mean when I kind of went sloppy here. I'm like, well, I'd have to have a little bit more knowledge about that graph. Good enough though, right? Just we're going to get a sense of how the derivative looks like. Cool? All right, now. This one's fun. Here, I'll make this thing. Another trig graph. Another trig graph. I like trig graphs. Anybody know what the graph sine of x looks like? Of course you do. Right? It's like a prerequisite skill. Can we just graph the sine of x curve? It goes like this. It goes like that. Right? Y equals sine of x. Hey, does anybody know what y equal to cosine looks like? I'll put it over here. What's cosine of x look like? I'm just going to put it over here. Y equals cosine of x. So let me go like this, and then it comes down like this. Known great's got the phase shift. Very good. Isn't that cosine of x? Okay. Cosine of 0 is 1. What's the sine of 0? 0. But I was wondering, everyone, can you get the derivative? Make a rough sketch of the derivative. All right, where's the slope 0? Boom! Right there, the slope is 0. What about here? Boom! Slope is 0. What's the slope in the middle? 0. That's slope right there. Positive or negative? By the way, I should say that if someone was sitting here the whole time going, I don't know how it's positive or negative. Yeah. Lines that go up from left to right, positive. Lines that go down from left to right, negative. I should say that. There could be someone here who goes, oh, I didn't know that. So that's a positive slope. So I just put it what, up in the air? Yeah. There we go. Over here, looks like it was what, negative? Over right there? Negative? All right. It's going to be smooth. And guess what, everyone? Guess what the derivative of sine of x is? Take a guess. You bet. And we're just going to make this connection. Guess what? If y is sine of x, guess what its derivative is? It's just something you can really kind of see it. If y equals sine of x, the derivative of y equals sine of x is cosine of x. And so now there's a whole section in the book for trig derivatives. So don't worry about trig derivatives yet. Sometimes we discover these things as we go along. They're like, we didn't prove it, but we're pretty sure. We can see, oh my gosh. You know, these trig functions, they both behave very similarly, but there's a phase shift going on. That's what's going on.
So y cosine of x is sine, y prime sine of x.
Ooh, I like this. If y equals cosine of x, he's investigating this now. See, I love when you do this stuff. You can play around with it. Well, what do you think it is? I'm curious.
Would be y prime sine of x.
Sine of x?
Yeah.
Play around with it. You're close.
Sine of x?
Who nailed that? Who was that? That guy just hit it. Hey, if you played with it enough, you would tell. You'd be like, oh, it's complete opposite. And you would have flipped. You know what makes a graph flip over? Just a what in front? The negative. I'm serious. Sometimes it's fun to investigate it. You're like, can I figure this out? And so if you play around with these graphs, you can see the derivative of cosine of x is actually a negative sine of x. Hey, don't worry. We'll give you. Remember my JVC thing for jumps vertical? I'll give you something that helps you remember sines and cosines. Okay. I'll just give you a little. When we get to that, and when that's after the next test, I'll just give you something like this. And you'll just go, derivatives go that way. The derivative of sine of x is, the derivative of y equal to cosine of x is, yeah, you can just write it down.
Oh, I understand.
Hey, here comes my next one. This one, everyone, I'm stealing from the textbook, but I changed it a little bit, so it's not the same one. But I thought it was very interesting. Is there anything that could trick you? I'm serious, you're like, there's no way you can be stumped on this. Yeah, but so let's look at something strange. Sometimes the strangest ones are the easy ones. Like a straight line. Now, does anybody know about straight lines and their slopes? They don't change.
Zero?
Well, if it was like this, the slope would be 0, right? But what do we know about the slope in terms of if it's a straight line like this or this? The slope remains the same. The slope is constant over the entire portion of that line, right? Forever and ever and ever. True? That's different than these parabolas and stuff. The slope changes. That's why you have the calc course, right? Change in slope. But if it's a straight line, the slope is always staying constant, true? So, let me just put a graph here. Here's the one I made up. It's not the same as the book. It's a little different. I just thought I'd do a... There you go. Let's say there's some function doing this. So this is strange. And when I don't see these nice smooth hills anymore. So how do you deal with this one weird case? Well, they're straight lines. And the slopes always stay the same, right? So how about, that's what we'll look for. I don't see any hills, do you? So what I'm going to tell you right now, there's nowhere where the slope is 0. You go, isn't the slope there 0? Oh no, the slope does not what? The slope does not exist there. It's a corner. Everyone agree? So we'll talk about what we'll do with this. If the slope doesn't exist here, that's a corner. Does the slope exist there? No, so we'll figure out how we're going to represent that if it doesn't exist. A lot of you already know. But for this thing, everyone, all I know is the slope is constant. Just tell me, is right here, is the slope positive or negative? Negative. So if the slope's negative here, along this entire portion, okay, then I'll just do this. But I'm drawing a flat line. How do I know it's flat? Why do I know it's just somewhere it's negative, but why do I know it's going flat? That's right, it's constant. I'll give you, let's make up a number so people could see this. Sometimes it helps. And we'll make up a slope here. What's that slope? M is negative 2, right? What's the slope right there? M is negative 2. What's the slope right here? M is negative 2. It's not changing. It's always negative 2, right? The slope is always a negative 2. The slope is always negative 2 until it gets to this corner. Where do I got to put that corner? An open what? Open circle. Wait, the slope is always a negative 2.
No, I mean the open corner.
Oh, remember? Because derivatives do not exist at j's and v's.